All right, these are the work problems, the last section of notes for Chapter 11, Unit 2. The formula we're going to use is that work equals rate times time. The work is always going to equal 1. That's always, always, always going to equal 1. You can kind of think of it as getting 100% of the job done. Okay, so you're always 1. In our first example, the fill pipe can fill an empty swimming pool in 5 hours. So by itself, it can fill the pool in 5 hours. If the fill pipe and the garden hose both run, it takes only 3. How long would it take to fill the pool with just the hose? So I'm going to set this up kind of similar to the way we did the current problems. I'm going to switch the slide. It does have all the answers on it, but I'm going to talk through it as we go. All right, so for the fill pipe, I wrote W, R, and T for work, rate, and time. The work I knew was 1. Let's see if I can do it in purple. So I filled that in as 1. And I knew that fill it up by itself, that the time was 5. Now, to get the rate, I could kind of plug in and solve to get the rate. I did that here. Or using literal equations, you can solve for the rate, and the rate is always going to be the work divided by the time. So I got the rate by putting the work over the time. For the garden hose, the work was 1. The time by itself I did not know. That was x. And the rate was 1 over x. Now, when they work together, they're both accomplishing the same goal. So it should be faster with both of them working. So the work was 1. I added their rates because they were working together. So the rate is the sum of the individual rates. And then the time was 3. And what you'll see down here is that I did it in 2 different ways. They get the same answer. I just want you to see your options. So in the first one, I distributed the 3. That's over here in green. Then I found the least common multiple was 5x. I multiplied everything by the 5x. You can see some of the canceling and solved. Over here, it's the same problem. What I did first was divide both sides by 3. That's where the 1/3 came from. Dividing this side by 3 cancels to 3, and then this becomes 1/3. The least common multiple of 3, 5, and x is 15x, so I multiplied everything by 15x. That took me to here, and I solved. Either way works. Do the one that works for you. And again, push pause as we go through, or listen to replay it if I go too quickly. So in the next one, I'm going to do a similar idea. If you would like to try any of these yourself, as I move to it, you can just push pause, try it yourself, and then come back for the answer. So Peter can mow the lawn in 40 minutes. John can mow the lawn in 60 minutes. How long will it take for them to mow the lawn together? So for Peter, you can see I filled in the work was 1. His time was 40. I talked to you about the rate is always the work over the time. For John, I did the same thing. Okay, work was 1. Rate was 1 over 60, and the time was 60. Work is always 1 equals, when they're working together, I added their rates, and I don't know the time they work together. So notice this is different from the first one because the x is in a different location. Okay, and again, you can solve this in 2 different ways. I don't think I finished doing this one. You could, let me see if I can delete this for you. You could distribute the x on both sides, but you should get 24 minutes. So after you solve this, however you want to solve it, if you didn't get 24 minutes, just bring it in and show me, and I'll explain why. Now down here, if you have the printout, you're going to need to flip these 2. I had the wrong times in the wrong order. So for the faucet fills the sink. The drain is clogged and can empty the sink in 10 minutes. If the faucet and the drain are both open or both working, how long will it take for the sink to overflow? So I'm going to start here in the organization. Faucet, the work was 1, the time was 8, so the rate was 1/8. The drain is over here. I think you'd be pretty comfortable, I would think, with those ideas. Now, when I set this equation up, think about a faucet and a drain. Are they both working toward the same thing, or are they working against each other? In this one, they are working against each other. Okay, so I'm going to subtract the rates. When you're worried about subtracting the rates, first of all, the bigger one's always going to go first. But you can also look here. When both are happening at the same time, who wins? When both are happening at the same time, Does the sink empty or overflow? Overflow, which means the faucet must be faster. So that's why the 1/8 is first. All right, I solved that here. I divided both sides by x. Again, you can do it a different way. That's how I went to this step here. And then I multiplied everything by the least common multiple of 40x. That took me to here, and I solved and got 40 minutes. And again, I know I'm moving, so just pause, go back, whatever you need. For the next one, I would like you to push pause. I would like you to try these yourself and then come back. All right, so for Katie, we have the work, the time, here's the rate. For Becca, I don't know how long it takes her to go by herself, so I put the X there. Now they are both sweeping. They're both trying to do the same thing. One's not sweeping and one throwing dirt on the floor. They're working to accomplish the same thing. So in this one, we're going to add the rates. Okay. So I have the rates added. The time was 10 when they worked together. Again, what I chose to do was divide both sides by 10. So that's where this second line of red came in. The least common multiple was 20x. I multiplied everything by 20x, and I solved and got 20 minutes. In this one, which again, I'm hoping you tried. If you didn't, push pause and try it, then come back. All right, so I have Peter, his time, his rate. I have Carl, his work, his time, his rate. And again, they're both digging a hole. One's not digging and one's filling out. They're working together to accomplish the same thing. So I'm going to add the rates. Again, personal choice. This is what I like. I like to divide both sides by x. Again, you could have distributed. You should get the same answer. I divided both sides by x. That's where the red line came from. I multiplied everything by the LCM of 30x. That took me to here, and I solved. All right, for the last one, Tyler's selling lemonade. So he's putting cups on the table. People are coming by, and they're taking them off. We know how long it takes him by himself. So that's where this is coming in, okay? I also want you to note before you should push pause and try this, that look, after 30 minutes, the table is full again. When both are happening at the same time, what is the result? The table fills. So that means Tyler must be faster. So Tyler's rate must be a faster, and therefore, in this subtraction rate, put Tyler's rate first. The people, I don't know how long, the time for how long the people work by themselves, so that's the X. So this is subtraction. They're working against each other. Again, Tyler is faster. I figured that out because when both were happening at the same time, the result was a full table. So the fill must be faster than the empty. I divided both sides by 30. I multiplied by the LCM of 90. And I solved for 45 minutes. So that is the end of the work notes. And we will work on those problems later.